statement here in the first one. Might be a little unfamiliar with us. The first day I introduced similar, or we did ratios, I introduced, this is a different way. This is a different way to write a ratio. If you don't like the way this looks, rewrite it then. Anybody remember what this is another way of saying? FC over DB equals AC over PB, all right? So if you don't like the way that looks, you can, by all means, rewrite it. These sides are not in proportion until I know what? Triangles are similar. Whoa. Look how many triangles are in that diagram. You're just going to pick the ones you feel convenient? How are we going to find which triangles to prove similar? Any idea what's already up here? What's already up here, guys? What can we use to figure out what two triangles to prove similar? It's already up here. It's going to help you out. Will, what's up?
Is it the ones that contain the ones I want to prove?
Right? I'd probably want to prove a triangle that contains FC as a full side. So here's what I need you to do right now. Look at segment FC. Find a triangle where FC is a full side. And it should only be one. If FC is a full side in two triangles, I can't use it yet. So can you find a triangle right now where FC is a full side in one and only one triangle? Here we go. 5, can you find that triangle? FC is a full side in what triangle?
FC is full side in triangle AFC.
There we go. And that's the only triangle it's a full side in. So I got one triangle. How do I find the other one? Keep looking at the sides in the ratio. I got DB. Is DB a full side in one triangle only? You're darn right it is. Help. What's the other triangle I need? 13? Boom. 9. DBP. Nice job, guys. So we've determined the two triangles we need to prove similar. Now this is what we did all day yesterday. What's the main method? In a proof, what's the main method I'm going to use? Angle, angle. All right, so I'm going to need your help. There's a lot of givens up there that'll help you find those pairs of congruent angles. So take a second, look through your givens. Where can you find a full pair of angles in both triangles? Great midterm review here. Anything? 7, anything?
Angle BDP is the right angle.
Yep. Don't tell anybody why. And any other right angles up there? Yeah, go ahead. Yep. I'm not going to put both in the same statement because they are right angles for two different reasons. All right, so first one Amy gave us was angle BDP. I'm going to ask somebody right now why that's a right angle. So angle BDP is a right angle. Why? Why is BDP a right angle? Any ideas? You know already, Amy. 6? That's because perpendicular lines form right angles. Different reason why AFC is a right angle. That's a right angle because 14? I'm good with that. Yep. Altitudes form right angles. Definition of an altitude. Like it. Definition of an altitude. And now what do you still got to tell me about the right angles? They're congruent. Yep. Just like we did yesterday. We're just going to extend our proof one more step. Right angles are congruent. Still need to find another pair for me. There's another pair lurking up here somewhere. Another pair of congruent angles. Where are they? 3. Any idea? And here's a hint. There's one given I haven't touched yet, and that's going to help me find that pair. Yeah.
So AB equation, that means that
There you go. Don't tell me why. Okay. Appreciate it. Angle B congruent to ACB. He is correct. Why is young Sean correct? 13, 14. There you go. Congruent angles across from congruent sides. Good work. Now we know they're similar, right? Just got to write a correct similarity statement. And that's what I'm going to hear from 16. Want to write a correct similarity statement?
Okay. So triangle. What?
Triangle.
Oh, I thought you just stopped. Sorry. Triangle AFC
Okay, AFC.
is similar to triangle PDB.
Nice job. By angle. Make sure, again, all seriousness, definitely for tomorrow, make sure you got the similar symbol, not the congruent symbol. And now that the triangles are similar, I now know the corresponding sides are in the same ratio. And I like to call this the cousin of CP-CTC for congruent triangles, and that is corresponding sides in similar triangles are proportional. CSSTP. If you want to take a minute, let it roll off your tongue. CSSTP. Okay? All right. We're almost done here. Short day. Get to go on to the homework again. All right, we got a parallelogram. That's all I gave you. That was a parallelogram. Can you prove those two triangles similar? Prove those two triangles similar, given only given it's a parallelogram. So can you give me two pairs of congruent angles, knowing it's only a parallelogram? $16. See any angles there, Maggie?
Yeah. Angle DEC is equal to BEF.
There you go. Got the verts right away. Congruent to BEF. Vertical angles are congruent. One pair. Anybody see another pair? 12, see another pair? You're on the right. I don't have to hear, Emma, but go ahead. Where are you going with that? Which just get me the angles you want congruent, and then I'll talk about how to get them there. Where's the second pair? EFB. Yep. What type of angles are those? Alternate interior, but they're not congruent. And Emma was getting there. I just cut her off. They're not congruent unless the lines are parallel. Are the lines parallel? DC and AB. Well, I'm not. Can you say extension, extending it out? Yes, that's fine. Okay, let's do that then. Okay, I'll do that then. Before I say the extensions then, what do I need to say? The original pair are parallel, DC and AB, before I extend them. Why are they parallel? Well, why are those parallel then? A3, why are they parallel? Now you can extend it out and say not only is DC parallel to AB, but it's parallel to AF. Yep. Extensions of parallel lines are parallel. Now I want to make just a quick comment. Was anybody going to shoot for these two alternate interior angles? Because if you were, you don't need to say extensions there, because it's kind of already part of AB, so you wouldn't need to say. If you did, totally still okay, but if you didn't, it's fine. This one, though, we do have to extend it out because it is F. And now tell me those two angles are congruent. So angle CDE is congruent to, can I say angle F? Yep. Parallel lines imply alternate interior angles congruent. Nice job, guys. And then you guys know how to finish this even part B off. Triangles are similar. And then the corresponding sides are in proportion. Everyone feel comfortable with these proofs? This could be a proof tomorrow on the quiz. You ready to do a little more algebra? Got the calcs ready to fire it up? There's some extras up here if you need them. Here we go. Let's get it fired up. AB parallel to CD. Boom. Find the value of x in simplest radical form. Time out. Hold on. Before we do anything, I kind of already gave you a hint on where this was going. What's up, Sean?
You said X in simplest radical form.
Yeah, hold on. I said simplest radical form.
So,
It's got to be, we're going to end up using what then? Yeah, because if you ended up factoring, you don't get a radical when you end up factoring it all. All right, so that's how I know, boom, boom, boom. Probably going to, not probably, definitely going to use quadratic formula here. So that saves us some time to, can I factor it? Can I not factor it? I already told you. It's simplest radical form. The only thing we have with the radical is the quadratic formula. All right, before we use it, though, got to set up a good proportion. Side splitter? Yes, no? Nice. Not side splitter. I'm going to take away the easy part from somebody right now. 4 over x plus 3. X minus 1, I'll take away that easy part. And I'll leave the hard part up to somebody right now. What does, first of all, don't tell me the numbers, but what does FA correspond with? FA corresponds with FC. So I need a help from 5. What are you going to do, Mike, to figure out how long FC is? What am I doing to these two? Yes, and I appreciate it tomorrow, guys, if you did it off to the side and not try to do it in the proportion. I think that might come up with some difficulties there. Go ahead, Mike, combine. What is it? X
plus 1.
There we go. X plus 1 up here. Everyone all right where that came from? You're going to have to do it tomorrow. We ready to cross these up? Oh, hi, Emily.
Could it be x minus 1 over 4 equals x plus 1 over x plus 2?
Okay, let me ask you this question. You can answer that question yourself. Are you cross multiplying the same things we are?
Yeah.
Okay. Yeah, then you can set it up that way. Yeah. Couple different ways to set that up. All right, help me out. I'll go this way. 4 times x plus 1. 4x plus 4. And I'll ask somebody in a second what they ended up doing or getting after they double distributed x plus 3 and x minus 1 together. What does that one come out to be? 9 when you're ready, let me know.
X squared minus 1x plus
Minus 1x? You sure? You should have 3x, positive 3x, right, Justin?
Yeah.
And minus x?
Yeah.
So that doesn't come out to be 1x. That comes out to be... You did negative, you have negative x, right?
Yeah.
And you have positive 3x.
Yeah.
When you combine those, what do you end up with? Negative x,
Negative 2x.
negative x, positive 3x.
Oh,
Positive.
2x.
Okay, good. Everyone else all right?
I was just a couple steps ahead.
Because what you get negative x here plus 3x. Combine those, you get 2x. And then what's the number here, Justin? Minus?
Minus 3.
Yep, there we go. Everyone else on the same page here? Okay, move everything over, get one side equal to 0. So I got x squared. What happens when I move that 4x over? Minus 2x. And what happens when I move the 4 over? Negative 7, yep. Don't even try to factor. We already know it's quadratic formula. I'll give you the sheet tomorrow that has the formula on it. X equals, what's your b value up here? Negative 2, but when I plug it in? Plus or minus. I shouldn't see you guys plug a thing in here tomorrow other than the the store keys in your calculator. I just want to see a number here tomorrow. Just want to see a number. So go ahead, store A, B, and C in. Anybody want reminders here? We all good? How to store and then get b squared minus 4ac? Last call, we want to review that. Are we okay? Okay. Whenever you're ready here, number 9 again. Just let me know what you got underneath the radical. Redemption, that's why. 32, redemption. All over. 2. Simplest radical form. So I'm looking for people to break down 32. And keep in the back of your mind, when we review this, we always pick the biggest perfect square. Not all the time is it the first one I come across. When you're ready, biggest perfect square that goes into 32. Number 1. Not here. How about 12? Biggest perfect square. 16 times what, Emma? 2. So when I rewrite this, what am I going to rewrite radical 32 as? 4 radical 2 over 2. Got it. We're getting there. Simplest form, though. Everyone remember, this denominator of 2 applies to the left and to the right. To the left and to the right. What is it going to simplify to? Here you go. Let's hear from somebody. Here we go. 4. What's it going to simplify to? Ready? Left side first, Rachel. 2 over 2. Okay, got to write the 1. Plus or minus. Go to the right side now. 2. Don't. Just stop while you're ahead. You can't. Why can't I combine these? The 1 does not have a radical 2 with it. I can only combine things with the same radical underneath. That's as far as we can go. Well, I haven't boxed it in myself. I haven't told you guys to start the homework. How easy we forget. How many answers do we have up here? 2. Ready? Everyone go to your calculators. What's one of my answers? 1 plus, go ahead, 1 plus 2 radical 2 right now. 1 plus 2 radical 2. Everyone see that number you have in there? If I plug that in any place, would it give me a negative side length? No, it wouldn't, right? But what's my other answer, though? Well, stop. Hold on. I just did 1 plus or 2. Excuse me, 1. Let me get back down here. I just did 1 plus 2 radical 2. That was okay. But now go to your calculator now. 1 minus 2 radical 2. That's a negative answer. And if I take that answer and plug it in here, what's going to happen? Can't have a negative side length. Okay? So keep in mind. I know you guys are so used to rejecting answers when you factor, but when you use quadratic formula and there's a diagram. If there's no diagram, I'm accepting both. But since there's a diagram, I cannot have a negative side length. So this is the only acceptable solution. Questions from you guys? All right, get after it. You got plenty of time here to get after it. Check your answers as you're going along.